Okay, on the review, I only had one question was a couple of different problems. Starting off with number seven. Number seven. This one you'll probably have to have the calculator for. If it wouldn't have the two in front, you shouldn't need the calculator. But this one you definitely don't need the calculator. It's our absolute value one. The vertex is at negative 2, 0. So again, I'll just draw this out. Alright, so there's my XY axes. Alright, so negative 2, 0. Alright, and then it's up 1 over 1. So up 1 over 1 and in both directions. Alright, so there's that absolute value one. So that one, you should have no problem graphing that one without the graphing calculator. But the other one, you may need the graphing calculator for it. So what I'm going to do is this. I'm just going to go in the graphing calculator. I'll put it in there. So y equals, clear that one out, and just put in square root of 2x plus 4. Alright, so square root of 2x plus 4. And I'm not even going to graph it. I'm just going to go to my table. So second, and graph in the table. And I'm just going to look for my numbers where I have good numbers. So 0 is at 2. Negative 2 is at 0. So negative 2, 0. Alright, 0, 2. And then I have 6, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Alright, so it's going to look like this. Right? And then it asks you for the solution set. Well, the solution are the places where it intersects. So we have a point of intersection here, which is at 0, 2. All right, so 0, 2 is one solution, and then 6, 4 is the other place it intersects. So that is the other solution. All right, so there's two solutions, and there's the graph of it. All right. And then the other question I had was on number 11. All right. So number 11, to solve that one, we have 3 to the 2x equals 36. There's a couple different ways you could do this. We could get rid of this 3 by doing log base 3. So log 3. And whatever we do to one side, we have to do the other side. So they cancel out. So now I have 2x equals log base 3 of 36, and then I divide by 2. Divide by 2, and that is your answer in terms of a logarithm. So the first line you should put log base 3 of 36 divided by 2. And then the second answer, all you're doing is putting that in the calculator. So I'm going to use the change of base formula for this. All right. So I'm going to do log 36, enter. Divide it by log 3, enter, and then I'm going to divide it by 2. And there's my answer, and round it to the thousandths, so it's 1.631. All right, would be rounded to the thousandths. All right, approximately. All right, so that's those two. All right, and then we go to the applications. Alright, so the applications, the first one, all you really have to do is graph this and answer the question. I'm not going to draw the graph on there, but I would just graph it on here. So, again, I'm going to go to y equals. I'm going to put this in the calculator. So it's going to be, clear that out. So parenthesis, 3x minus 2, and my parenthesis, divided by parenthesis, x plus 1. Now they have to be in parentheses or it's not going to work out right. All right. And then I just hit graph. All right, I'm going to change my graph. It's at 5, so I'm going to move it up a little bit. So I'm going to go to negative 10, 10, negative 10, and 10, and then we'll graph it again. All right, so that's what my graph looks like. Now, this line that goes straight up and down here, that doesn't count. That is not part of the graph. All right, it just connects these two. So this line does not count as part of what you're asking you. All right, so the first thing it asks is, what's the x-intercept? Well, I can see the x-intercept right there, but to be sure, it's going to be when y is 0. All right, so I want to know when y is going to be equal to 0. That gives me the x-intercept, because again, the x-intercept looks like it's at 1, 0. I don't think it is though. But if I do second in the table, I can see 1, and I can see that it's not 1, 0. I think it's 3/4 or something like that. But you can do, in the calculator, you can do this. You can always set this equal to 0 and solve it. So we could do that. So we could take 3x minus 2 over x plus 1 equals 0. Solve this. Multiply both sides by x plus 1. They cancel out, so I get 3x minus 2 equals 0. Because 0 times x is 0, 0 times 1 is 0. And then I would add 2, get 3x equals 2, divide by 3, and we get x equals 2/3. So that is your x-intercept. X equals 2/3. All right? And again, I want to look at the picture of the graph to answer these. So it says, for what values of x is f greater than 0? So all that's asking you is when is your graph above the x-axis? Well, this whole thing is above the x-axis, and that is when x is less than negative 1. All right? So when x is less than negative 1, it's greater than 0, or it's positive. And right here, after it goes through, it's positive here. So it's when x is greater than 2/3. So that's when it's above the x-axis. That's all that question is asking you. The other question is, when is it below the x-axis? Well, it's below the x-axis in between these 2 points where it was above. So it's when negative 1 is less than x is less than 2/3. All right? And then the last question says, for what values of x is f increasing? So when's it increasing? So you look at the graph, always read it from left to right. Well, this one is increasing the whole time. So that's increasing the whole time. This part, again, over here, it's increasing the whole time. So it's increasing everywhere except when x is negative 1. So the answer here is when x does not equal negative 1. That's when it's increasing. All right? All right, and then the last one. All right? So number 2. This one should be fairly easy. You just got to remember this is in thousands. This is our formula. So that is your answer to the first one. That is a sub 1. All right? So it's since 2000, and they want the year 2000. So that was a sub 1. So it would be 425,000. Because again, it's in thousands. We take that. That's for our formula for our series. All right, geometric series. We said it's a sub 1 times the r, or to the t power. All right. All right, describe this city's rate of change of the city's population. All right, the rate of change of the city's population. Well, it is going up, and it is going up at what number is this, or what percent is that greater than 1? Well, the part that's greater than 1 is 0.06, so that would be 6%. So it would be a 6% increase. All right. And then the last part's the easy part. Is it exponential growth or decay? Again, all we got to do is look at that number. If it's bigger than 1, it's growth. If it's less than 1, it's decay. This number is 1.06. That's bigger than 1, so it is growth. And the explanation, 1.06 is bigger than 1. All right. And then the other one, the next two terms in the sequence, well, if you look at this, it looks like if we check this, it's we do 32 over negative 64, which is negative 1/2, negative 16 over 32 is negative 1/2, 8 over negative 16 is negative 1/2. So you can see it's it's definitely geometric. All right, it's a geometric series. So all they're doing is divide by negative 2 each time. So if I take 8, divide that by negative 2, my next term is negative 4. I take negative 4, divide by negative 2, and it's positive 2. So there's my next two terms. All right, because it asks for that. And then it asks for write the pattern. Well, the pattern is easy. A sub n equals a sub 1, which is negative 64, times r, which is negative 1/2, to the n minus 1 power. And there we go. All right.